Okay. Hello, everyone. Good morning, good afternoon, and good evening, based on your location around the world. Greetings from All India Oracle User Group. We hope you and your family is safe in current situation. I would like to welcome you all in our AIUG webinar, which happens every Wednesday. Today, we have a session on database fleet modernization with Oracle Autonomous Database by Chris Bhanushali. Chris is a senior principal product manager at Oracle in Redwood City, responsible for database cloud service. Chris has been working with Oracle for 10 plus years in various roles in sales, developer advocacy, and product development. Prior to that, he spent 8 years in managing database engineering teams for US financial institutions. Chris is also a hands-on hacker and an avid public speaker. He has presented technical sessions as well as Oracle Cloud Strategy at events worldwide. During this session, if you have any question, please ask your question in Q&A panel and we will take those questions in Q&A section. Currently, we are using two channels for this webcast, Zoom and YouTube Live, and presentations will be shared with registered participants. You can view the presentation after filling speaker survey. Watch out your mailbox for survey link after the session. At the end of the session, we will run a quiz. Please participate to win raffle prizes. Hi, Chris. Thanks a lot for being here, taking out your precious time for this session. Please unmute yourself and start the session. Chris, can you please unmute yourself?
Yes, thank you once again for the great introduction, and welcome everybody to this webinar on database fleet modernization with the Oracle Autonomous Database. Once again, my name is Chris Bhanushali. I'm a product manager for the Autonomous Database Cloud Service at Oracle. Just a safe harbor statement in case I speak about product direction. There might be some slides that talk about features that are upcoming. Overall, the agenda is pretty straightforward. We're going to look at the AI revolution pragmatically and look at the impact that it's having on all aspects of our life, including the way databases are managed. And most of it is, of course, a technical deep dive into the autonomous database, helping you understand how you can leverage autonomous in your organization, what it means for you. And some of the key differentiators that I talk about, we'll also take a look at it and see how it works in action. Now, I think everybody on the call here is familiar with AI, understands the impact of AI. And if you take a moment to absorb all the different areas where artificial intelligence and machine learning has impacted our lives today, it's phenomenal. And you realize that every aspect of our life, whether it be the way an airplane lands, for example, or the way you use your smartphone today to do language translation, browsing for products, even things like healthcare, agriculture, the way we grow crops, and which season is best for which crop, all of that is being driven and impacted by machine learning and AI today. So it's a no-brainer that something as important as technology management would have it has to be impacted by AI. And an autonomous database, and I get asked this question quite often, that what is the autonomous database? And so in very simple terms, autonomous database is the application of AI, modernization of databases, right? Application of AI to database management. This is like any other evolution. AI impacts database management as well. It has to, as I said. And who other than Oracle to bring this to their customers? We've been in the database business for a very long time, over 3 decades. People familiar with the Oracle database understand that it's always been about innovation, and we lead the market by a long shot in terms of the innovation that we bring to the database platforms. And so regardless, every vendor is going to choose and is going to have, AI-based autonomy and management capabilities in their services going forward. Except Oracle has been the leader, and we lead the market by almost a decade. And so hopefully through the rest of the presentation, I will be able to show what that means and how that impacts day-to-day manageability of databases. Now, a couple of slides to indicate what the market perception is of the Oracle Cloud as well as the Oracle database services. This is a Magic Quadrant from last year by Gartner. And as you can see, Oracle is rated at the top right. And this is not just database. This is very specifically related to data management solutions for analytics. And the result of autonomous databases is we are more and more in the leading quadrant, even for cloud services. A similar study done a little bit later by Forrester, which is very specifically for database offerings in the cloud. And as you can see, we are at the top right, tied, neck to neck with AWS from a cloud perspective. Now, and the reason for that is, of course, the autonomous database, the vision Oracle has for how data management will happen in the next decade or two, and the breadth of services and the choices that we offer in the Oracle Cloud. As you can see, this is a very busy slide, but to summarize, what it means is that all the way from commodity class virtual machine-based databases to autonomous databases that run on your own dedicated platform as a private cloud in a public cloud offering or at cloud at customer, there's a wide choice of database services so that you can make your journey, basically. And I'll explain what I mean by that. The journey from managing and worrying about databases and administering them yourself to more towards autonomy, where you are now able to focus on things that matter to you and allow the service and the automation and the AI to take care of managing the databases. So on the extreme right, as you say, the autonomous dedicated platform is such a platform that allows you. And we realize it's a journey. And so you can see that, you've made sure that all the steps in the journey are covered. Just to give you an idea about how quickly the Oracle Cloud has expanded and how serious is Oracle as a contender in the cloud space. This is a map as of Feb of this year, 21 regions across the world. By the way, AWS today has 20 regions, so we are already ahead of AWS in terms of the number of regions where we provide cloud across the world. By end of 2020, we are planning to be in almost 30 regions across the world. And not to mention that, we have a wonderful partnership with Azure. And as you can see on the slide, in places where you see the Microsoft logo, those are the places where we have data centers very close to Azure, such that customers can run both .NET workloads or any other workload that they might run in Oracle or Azure and share the two clouds. So a possible scenario could be customers who already have an existing footprint in Azure and are running their apps there, but would rather run the databases in the Oracle Cloud for the value that it offers, can actually do that because of the infrastructure and the way that the two cloud regions are set up with each other. So why would you pick the autonomous database? And I've distilled it down to about 5 key aspects that I think you should take away from this presentation in terms of what the autonomous database can do for you. Number one, it is designed so that it reduces your ongoing maintenance. And all the automation that we'll talk about is geared towards that, to take stuff that you do not care about, the regular day-to-day churn of manageability, patching, backups, all the typical things that on a routine basis do not add value to your work, but take away valuable time, those things have been taken care of by the automation. So that's number one. Number two, what is important to our customers is improving the uptime. You have business demands to keep your applications up and running, chugging 24/7, providing value to your business. And key goal of the service is to be able to do that. Hopefully, we'll also be able to see that live in terms of how that actually works. Security of, across the service by providing a very standard service. Not only is the configuration secure, but many different aspects of the service where securing those assets would be a challenge given the width of the fleet you might actually have. Focusing on security on-prem can also be a challenge. And so by automating a lot of these security features and standardizing, we provide better security on the autonomous database is what we believe. Of course, availability in terms of the way it offers DR and recovery services. And in the end, it's also about enabling your business, your developers who are building services and applications that matter to your company, enabling them so that they can get their jobs done easier and faster. Now, I have been involved with the autonomous database service since day one, since the first requirement was written, and was lucky to even participate in writing the original requirements. And I would say, of all the things that the autonomous database offers, the highest value distills down to about 6 key tenets, as I would call it. It deploys on the world-class Exadata infrastructure, which many of you might know is one of the best platforms to run the Oracle database on. And by providing a provisioning mechanism where we simplify the provisioning of Exadata hardware, infrastructure, rack, data guard-based replication, cloning, all of these features, which can take reasonable amount of time on-prem. By providing a very simple way to provision them, we reduce the time it takes to get an enterprise class production-ready database, up and ready for your application. So that was ease of provisioning was definitely a big factor. Security, again, given our customer base, we serve the world's top financial institutions, the world's top retailers, the world's top telecom, people for whom consumer data is life and blood, and we understand security in and out. And it was important that we bring the security automation to our service, and so that has been a key focus. Manageability, as I said, the whole automation is geared towards managing the service such that these routine tasks, such as patching and whether it's the operating system or the database or the infrastructure or the hypervisor, the entire stack, is completely taken off of the hands of the customers so that they can focus on things that are more important to them. So a lot of automation is built into the service. This is also where the AI part helps in terms of making sure these tasks are fail-proof. Enough prediction is in place in terms of performance management, for example. And so we'll take a look at some areas where not only in the service itself, but also in the database itself, how Oracle is expanding what it can do with machine learning and automation to make sure that we are able to standardize and take care of maintenance activities. And then the other three are, of course, protection from failure, or in a way, protecting your application from any outages. And there's a variety of features that Oracle has built over the years that have come together to provide that level of HA that your application expects. We'll take a look at some of that and also see how, when you scale or when you perform any maintenance operation, how on the database, how can the application stay on and available to your business. Scalability, as you know, is the promise of the cloud. That is one reason why people want cloud to be able to get databases infrastructure on demand, not have to pre-plan, and expand and contract what they're consuming based on their business demands, so that they're not pre-investing, right? And so scalability is always a very key aspect. Except in the Oracle Cloud, you can actually scale while keeping your application up and running. That is super important to our customers. People cannot take applications down because there's a backend scaling operation. And so the value of scaling greatly reduces if you have to shut down your application. In the autonomous database, you do not have to do that. And then finally, optimization. How do you run your workloads without human direction, even from an application standpoint? So there's a lot of automation that is being built in the database service or the database itself that manages parallelism, that manages the optimizer plans better so that the best path to the data, the fastest path to the data is what is picked without human intervention. And for example, automatic indexing was one such feature that was introduced in 19C. And so both the service as well as the database are focused on making sure that databases become easier and easier to consume as a service. And hopefully the idea is just like you use your smartphone very quickly, you get the work done and you move on with your life, is how you would also operate large fleets of databases in your organization in the future. Now, I've made a few claims in the last couple of slides, and I thought it would be nice for me to even show you how some of those things work. So what I've done is, in the interest of time, I've prepared a short viewlet, and I'll play that, and I'll speak as it goes on to demonstrate how online scalability works. For example, let's get this rolling. So I'm logging into my Oracle Cloud Infrastructure account. This is what the console to the cloud service looks like. On the left-hand menu, I pick the service that I want. In this case, it's an autonomous transaction processing service. And I can see all the databases that I've created in the compartment, which is a way to separate my databases. So I go to this database that I've created called SBATP3. And I see that this database is running with 3 OCPUs. That's how I've created it. And I decide, okay, my application needs to scale. So to demonstrate how this works with the live application, I'm going to run an application in the background called SwingBench. SwingBench, you might know, that is a workload generation tool. So I'm going to use that Java application typically like any other Java app. And I'm going to fire up this app. And I'm going to connect it to my database and run this application. So reset the password to the username. SOE stands for, I think, sales order entry. Yeah. So it's an order entry application. And as you can see, SBATP3 is the connect string. This is what I'm going to connect to. And to do that, of course, this is how you would go ahead and get the connect string from the service. So very easily go to the DB connection settings, copy and paste it here. That's all it takes. I run a quick test to see if my connectivity succeeds. And yes, I was able to connect. So now I can actually fire this workload off. On the right-hand side, just to quickly see that this is a good mix of inserts, updates, and selects. It's a very typical mix, just like a traditional OLTP application. So I fire off, and as you can see, about 100 users are being simulated in this app. So all of the 100 users are now connected, and very shortly you'll see the DML operations come across. By the way, when I recorded this was done from my laptop here, right here where I live, and then the database is on the East Coast. This was connected to our Ashburn data center. So of course there's a big round trip, right, about 3,000-mile round trip, and so you might see some delay in terms of the connections, but that wasn't the point, so I think it's okay. Now, so on one hand, so now I'm going to show how you scale up and down. So, right, so my workload is running. I'm going to go up from 3 OCPUs to 6 OCPUs. And there's also auto scaling. So what we're doing today, right now, and I'm going to pause here to help you understand what that is. What we're doing is manual scaling. That is somebody, a person is going in and saying, I want to scale, right? We're taking a look at that. There's also auto scaling. All you got to do is check that box on your service to say, whenever the workload crosses a particular threshold, automatically scale up, right? So it scales up, provides whatever OCPUs are needed. You can scale up to 3x of the base number of CPUs you have assigned. And then when everything is back to normal, it can scale down. So this allows you to, without any human interaction, making sure that your application has the resources and not having to pre-allocate those OCPUs ahead of time. So this really, from a cost perspective, you can imagine how that plays into your overall consumption of cloud resources. So here you can see that the scaling is now in progress. And I'm going to go back to my application and take a look if anything happens. No, everything is good. I do want to point out that these occasional dips that you see are a result of the latency that I talked about earlier and have nothing to do with the operation that any of the backend operation. So my workload is chugging along, no problem at all. And it takes about, I would say, 2 to 3 minutes for the scaling operation to complete. And so I'm going to go back and check, and just after a few minutes when I checked, everything's available, OCPU count has gone up. So as simple as that. This is all it takes to manually scale. And if you set up auto scaling, as I said, you don't even have to come out here. The workload will take care of itself on its own. Now, there's one other thing we can take a look at. I also mentioned a few times that your application need not shut down when a maintenance operation occurs or if there's a failure in the backend, right? So the availability aspect of it and the online maintenance is a key marquee feature of the Oracle Autonomous Service. So I want to quickly demonstrate how that works. Since we have the application running in the background, what we could also do is simulate a maintenance cycle by, say, recycling the database. So this, as you know, it's running on a Exadata rack cluster. And so if we recycle the rack where each node is taken down and the patching operation occurs and we start it, what we call as a rolling restart in Oracle Rack, then I want to see what the impact it has on the application and what actually happens. This is a comparative scenario to when an actual patching or a maintenance operation occurs on the back end. This is exactly what happens. And so you will see that you can set up your application such that they leverage a feature called transparent application continuity. Your application is basically transparent to any of the maintenance or outages in the backend. And you'll see that the workload can actually chug along unimpacted when such an incident occurs. So I'm just going to go ahead and play this. And first of all, I'm on this database that runs in a container called containerdb2. Now, I can restart containerdb2 here. But first, what I'm going to do is I'm going to connect to that database, and I'm going to see how many connections I have on each of the rack nodes. So I run this query on $session. You can see that because I have 100 users, about 104 connections on instance 1, and instance 2 has about 1 user. So now I can go to the container database and restart that container. This is the CDB, or the database instance that is being recycled. So I fire off the restart operation, and you'll see how this entire thing plays out. The console shows it's restarting. I'm going to go back to my query and see how this impacts the connections that are out there. So far, everything looks okay. I have to keep checking. Now, you can see very soon it starts draining the connections over. So you can see more and more connections start moving over to node 2. And as each transaction completes, a new connection in the pool is provided to the second instance. After a while, you'll see that node 1 has gone down completely, while all the connections are now moved to node 2. I go back and take a look at how the application is doing. It's still showing restart. The app is chugging along just fine. All the 100 connections are intact. My DML hasn't gone down. And so now I go back and say, okay, I see that node 1 has come back up. Node 2 still has the workload, but it'll do the exact opposite now. It will now start draining the connections over from node 2 back to node 1, and then take node 1 down. So you can see that it completes it in a rolling fashion. So let's go through that and see what's going on. Okay, it's already started failing the connections over on the other side. And after some time, node 2 now has gone down with all the connections now being on node 1. My database is still restarting. After a while, you see the database becomes available. And if I go and look at my workload, once again, no issues. Everything was as expected. So again, of course, I've cut down the times in between in the interest of time, but overall, this whole operation spans about 15 minutes right now to do a restart. That's what it took me. But the point here being, regardless of the number of times patching operations occur or maintenance cycles occur, you don't have to take the app down, which is definitely a big deal from an admin standpoint, because that's a laborious task. And as you know, turning an application down, all the different tiers of the app, asking business for that outage is such a painful activity. And even besides the outage that it actually causes on your business and the number of times you can actually do that. So what does this mean, right? And this is a study that was done by IDC. And, compared to running an environment on-prem, the savings that you get, the direct hard dollars that you save in terms of the efficiency of your IT infrastructure, the cost of operations, right? The reduction in IT infrastructure. I showed you auto scaling, not having to pre-provision large amounts of hardware, which rapidly decreases in price, as you know. You plan for 3 years of growth, you buy it 3 years, in advance, hardware that's going to reduce to, a quarter of its value at the end of the 3 years. If you add all of that up and the automation that it provides, they found that there's over 80% saving compared to a do-it-yourself or build your own database environment on-prem. So I invite you, when you get the slides, to click on that link and take a look at the study that IDC did on this. These are the customers that have put their faith in the Oracle Autonomous Database and have taken the leap to modernize their database fleets and take it to the next level. So let's get into the details now. So the Autonomous Database today is available in the Oracle Cloud in 2 flavors. We provide it on a shared infrastructure and on a dedicated infrastructure. On the shared infrastructure, as the name indicates, that Exadata infrastructure on which the Autonomous Database service runs is shared among customers. So this I would compare more like an AWS RDS type environment, multi-tenancy. The hardware frame has more than one customer, and it has its own value. You rapidly want to get a database, you want to run test dev, you want to run a quick app, low entry point, then this makes sense. Many lines of businesses would like, if you're running a quick reporting application, you need a 2.0 CPU database, for a period of time, and you can go to the shared infrastructure and get one. So that's one offering. The other one is the dedicated infrastructure, which is more geared towards IT. And I'll show you how IT can actually become a service provider within their own organization using this dedicated infrastructure service. And this is key. This is where CIOs and CTOs can strategically think about how they're going to manage databases going forward and leverage something of the sort of a private cloud that they have control of, that is not shared with other customers, right? Or a line of business. And so they can use that to modernize and manage efficiently, but at the same time retain enough control so that they become the service providers within their organization. So we'll come to that in a little bit. And so my focus in this particular webinar today, and since I've talked about database fleet modernization, which is management of your entire database fleet in the organization, how do you manage it more efficiently and better? I'm going to focus on the dedicated service because I think that's where the value is for fleet modernization. So the dedicated infrastructure, in a way, it provides a private database cloud. As I said, you get your own slice of Exadata infrastructure to begin with, right? So you can start with quarter, half, full. All three shapes are available in the Oracle Cloud, and you reserve that. So that becomes your hardware, and only your databases get created in there. Provisioning is simple. Going forward, I'm going to show you how databases are provisioned with a few clicks. You can provision Exadata infrastructure with the same ease. You click a few buttons and you pick the region where you want it, and you have your own full rack of Exadata with hundreds of cores and petabytes of data of storage. On that, you choose how you deploy databases. Databases are isolated. You can see that the Exadata frame itself, the network, container databases have the highest level of isolation, very comparable, I'd say, to how you would isolate environments on-prem. You have certain controls of operations. So you decide when a patching operation occurs, what version gets deployed. You choose the schedules, but you don't actually do it. You make those choices, and the automation and the machine learning and the operations staff of Oracle makes sure that that activity happens seamlessly on your database. And in the end, I also want to add that the same service is going to be available as a clouded customer offering, I would say around July, August timeframe. And so just to point out that is, that works better for customers who do not have a region at this time, or have workloads that need to run on-prem, right? And you cannot afford the latency. So for a variety of these factors, the clouded customer offering makes sense. But otherwise, whether it runs in the public cloud or clouded customer, the service experience, the features it offers are identical. Now, getting into the details of what the dedicated service is, and I mentioned about how this is crucial for an IT organization. You'll see that the service is designed with a set of roles in mind. And we believe that in an org, the IT staff, or the admins, are the small component of people that service the rest of the organization, which is engineering teams, development teams, that are the consumers, the business folks that consume applications and databases. And so by providing power to this admin staff and automating things for them, but allowing them to keep control of that infrastructure, we enable them to then provide database as a service to this organization, what I show on the right-hand side here, right? So it's a very seamless, easy experience for folks on the right, the consumers of the database, to go and get databases and create them without any intervention or human beings involved in there. But at the same time, it gives the fleet admins absolute control over how the infrastructure is deployed, the security of the network, right? Making sure the backups are happening in time, even if it's oversight. That oversight has to come from the fleet admins, who we believe understand understand the infrastructure, would understand the environment, and would control how cloud resources are consumed. So it's a nice separation of duty in a way between fleet admins and the rest of the organization. I've already talked to this, so I'll just quickly go through it. Customizable operational policies. So the fleet admins decide when patching operations occur, how backups take place, versions of the database software, allocating CPU counts to lines of businesses. So let's say the fleet admin gets a full rack of Exadata with about 400 cores, right? So now they can decide X number of cores go to this particular project or this line of business, this much storage gets assigned, so they can actually utilize or set up the hardware accordingly, create the compartments and set up the environment. And so they have control of all these things, very similar to how you would do it on-prem, which is important, I guess, to have a good cost and performance control of your database environment. If it is free for all land, then before you know it, you would find that there'd be thousands of databases in your organization that you have no control of, and it can be absolutely chaotic. A few use cases here. I've already talked about this one, fleet modernization. And by that, I mean the journey of taking pretty much every Oracle database that you might have on-prem and moving it to an autonomous management capability, whether it's using cloud at customer so that it stays within your data center, or moving some to the public cloud setting where it makes sense. This journey of taking your existing outdated database, whether it's hardware or the versions of the database software itself, and moving it slowly and as it makes sense to this new modern environment of self-managing databases. That's the fleet modernization journey, right? And so again, I'm not proposing that it's an overnight thing and you will be able to do everything over the night and move to autonomous. But all the steps, as I said, of taking this from point A and getting it to point B are there, right? And so as I showed you, many customers have taken the leap, and I invite you as well to join this. So that's the first use case. Now, you could start off, some customers say, I've always wanted Exadata. I have this one important application in my company. I cannot afford to buy Exadata, for example, or do not want to keep it, do not want to have a data center, a variety of reasons. You can now, provide that availability and that performance to that one app, right? By moving it to the Autonomous Database Cloud, get your own quarter rack, for example, to start small and provide the highest availability without jumping through hoops, to the application that matters. So that's like a simple use case of take one application and move it there. Another use case is potentially to say, okay, now can I consolidate? This environment is built for consolidation. There are controls in place such that even if you deploy 10 applications, you can control the performance impact, right? And so if you're running a data warehouse application right next to an OLTP app, you can absolutely do that because there are controls in place that ensure the number of CPUs, the number of connections, the IO throughput, the cache, all of that you desire for this OLTP app are reserved or available to them and are not taken away by any rogue query, for example, on the data warehouse side, that's massively parallel and trying to take all the resources. So these controls are available and built into the service, so you can consolidate more and more applications of different types on the same Exadata hardware. Now on the performance side, needless to say, of course, it runs on Exadata. So all autonomous database services run on Exadata infrastructure. And definitely it's been one of the best hardwares to run on. The latest X8s that we introduced give amazing performance, about 1.6 million IOPS for a full rack. A lot of NVMe flash. We changed in the X8Ms, we changed the interconnect. I'm sorry, not the interconnect, the InfiniBand to RDMA over InfiniBand. And so it's Ethernet based, more standard compared to InfiniBand. But in the end, the latency that it provides and the speed that it provides for access to your storage between your compute host and the storage it's amazing. And so being able to run large data warehouses, for example, or OLTP applications that serve thousands of customers, for example, becomes very, very easy. So needless to say, Exadata infrastructure is the thing. But also in terms of features that have been added to the database engine itself and to the infrastructure that allow workloads to run with maximum potential, features of Exadata itself, features of the database. The combination of all of this is what makes up the autonomous service. And so one such database feature is automatic indexing, right? And I'm sure many of you must have heard about it. Automatic indexing is important because indexing activity is one of the most, I would say, time-consuming performance management activity for a database, right? So for an OLTP application, what do you do when something slows? You first run the explain plan and look at it and find out that you could probably add an index, right, to speed up certain aspects of a query, and you go ahead and create that index manually. So that's that. And then over time, the problem reverses. You've added so many indexes that the database is now bigger. So every time you perform a maintenance operation, or you have to either drop those indexes, do your reorgs, build, rebuild those indexes, defragment them, all these activities kind of take a toll because now there are more and more indexes as time goes on. And so both ends, creation of the index is also time consuming, requires human beings, and it takes a change cycle because, between the time you see the performance impact and you create the index, that the application might actually suffer. And on the other extreme, having a large number of indexes and managing them. Both of these issues are solved with automatic indexing, where the ML algorithms keep a track of the workload, are able to detect if a particular SQL statement would work better with that particular index, and give that control to you, whether you would allow the system to automatically create that index or simply report on it so that you can manually create it, unless you build that confidence that the system actually does a decent job of creating the right set of indexes. So it eventually gets you there. But the point being that the entire index management is something that the machine does. It also can remove indexes that are not used for a period of time, right? So you can set the time period to say anything that's not been used for 6 months, for example, can be removed. And you have those knobs to tune how this works. But overall, it can take care of your entire index management. Now, I'm going to show that to you. So let's take a quick look at this demo. I'm going to run that same Swing Bench application on a brand new database. So this is also an opportunity to take a look at how how you provision a database. So we're going to start off by provisioning a database in the Oracle Cloud. Then we're going to build a brand new Swing Bench schema. So I'm going to run a script that creates my sample order entry tables, but I'm going to do it without any indexes. So I'll build my tables, no indexes. Then I'm going to go take a look at auto indexing setup inside the database. I'll see that it's turned off. Then I'll fire off my Swing Bench workload, turn on auto indexing, and I'll see what happens after a period of time and how it reacts and what it does. So let's take a look. So I start off by logging into my console. Let's go ahead and create a brand new Oracle Autonomous database. So you'll see how easy that gets as well. I go to the console, you can see a list of databases there. All I do is say create database. I told you can separate your databases by compartments. So I picked a compartment at the top, given a name to my database. I call it Swing DB5. And here I can pick whether it's a data warehouse or transaction processing, whether it's on shared or dedicated. Pick the container database, right, where I would like this database to be deployed. Pick the number of CPUs and storage. I've already talked about auto scaling. I'm going to give it a large number of CPUs at this time so that my schemas get created quicker. Give a password for the admin user. And say, create autonomous database. That's all it takes. This is all it'll ask you. It takes about 10 odd minutes to provision a database with these inputs. And once it's ready, you'll say it's available. Now that my database is ready, I would download the wallet so that I can connect to it. And as I said, all connections are secure. There's a few slides on security where I'll talk about this more. Download the security wallet. And now I'm going to go to my application. I'm going to copy the wallet first. So I'm just SCPing the wallet into my application host. I SSH to my host. And I have to basically in the SQLnet.aura provide the path to where the wallet sits. on that host. And so it sits in a location in my home directory. OPC wallet directory is where I've copied it. And so I just point to that so that the application can actually find the wallet when it tries to make a connection to the database. I export the TNS_admin environment variable, pointing it to the wallet directory. And once that is done, that's all. I'm going to fire off the script that actually creates the database schema. So I connect to the database and it's going to create a bunch of tables for the order entry application. Right, so I'm building my swing bench schema here. Now, let me just rewind a little bit so I can show you that. As you can see one of the parameters here say no indexes. So right off the bat, when I'm creating, I'm saying deploy it in this particular table space and give the passwords as needed. And I'm saying no indexes. So you'll see that eventually it creates that schema without any indexes. It took about 15 odd minutes for not a very large schema, still has a few 100,000 rows in the table, but about 5 gigs of data is what I created. And so in about 10 to 15 minutes, 10 minutes about, I had my schemas created. And once again, if you look down here, it says everything went right, except I'm missing indexes at the bottom, right? So missing indexes, which is exactly what we wanted. We did not want any indexes. So now I have my schema ready, no indexes. And I'm going to confirm that that's the case by connecting to the database using SQL Developer. And I'm going to select from DBA indexes and see if the SO user has any indexes. So this should return 0 rows if everything is right, which is fine. So I have no indexes. Now I'm going to take a look at the auto indexing. So this is a view that will show you what the setting for auto indexing is. Oh, sorry, I rewinded too far. Let's go back to the spot here. Okay, so I'm going to take a look at that, and it says that auto indexing is turned off, right? So you can see all the parameters. These are the various controls I have available in terms of which schema I want to include, how much space do I want to allocate, whether it's a separate table space for auto indexes altogether. So that way you have good control over auto indexing not getting out of hand, right? This is some amount of confidence that you need, before you eventually settle down and say this, this feature is doing its job right. But it gives you enough control so that you can slowly, get into it without losing sleep. So auto indexing currently is turned off, as you can see, and I'll show you a different way of turning it on. We could do it from SQL prompt, as I said, but I'm going to do it from Enterprise Manager. And first, I'm going to go ahead and register my target. So this is a brand new database, not being monitored by Enterprise Manager today, right? So I go to adding targets, add a target manually, call it autonomous transaction processing. So I give the target name, say that it's on dedicated hardware, choose my wallet to make the connection. And then I have to unlock the ADB SNMP user, which is what Enterprise Manager uses. That account is locked by default for security reasons. So I unlock the user, reset the password, and then I can make a connection. So that's all it takes to get Enterprise Manager to get working with the autonomous database. So I just did that. Let's go back and now enter the password and test the connection. So connection successful. I can now successfully add this as a target. And I now go to the console and connect to the database as user admin. And I can see that index mode is set off, right? So I went to the auto indexing page, which is under performance, and I see that indexing is off. I set to implement, specify the schema. The SOE schema is what I want to monitor. So you can include and exclude schemas, specifically. Apply, and once I do that, so this is another way. I just wanted to show you both the methods, ease of the UI based using Enterprise Manager, and also being able to do it through the SQL command. So now I start my workload. So I ran the same workload against the database, and I see that auto-indexing tasks there's a task running called the auto-indexing task. It's on, it runs every 900 seconds. So it's going to examine the workload, and 900 seconds is 15 minutes. And then after 15 minutes or so, when I ran this query to look at the DBA auto-index actions, I now see that a bunch of indexes have been created. Now I could have set this to report only. So it's up to you whether you would set it to report only or implement. We picked implement for this use case, but it does create the index first in invisible mode. And if you've set it as implement, it will then make them visible and usable, right? So as simple as that. So this is all you need to do. And from absolutely 0 indexes to it created all the indexes I needed. Now, I wouldn't say that this is the route you would take, that you would drop all the indexes on your OLTP schemas, but typically what happens is that beyond just the primary indexes, the other secondary indexes get built over time, and that's where the real pain is. And so it addresses the problem exactly where needed. Leave the primary key indexes, along with the app the way it is, but allow secondary indexes to be managed by the auto-indexing feature would be the right way of making use of this feature, I'd say. A quick example of a complex application such as NetSuite, which is an ERP application. And when we ran these tests, dropped all the indexes on NetSuite and reran the workload and compared the performance and the number of indexes to an expertly tuned system. So on the left-hand side is when a human-tuned system with years of indexes created, having over 8,000 indexes for about 1,800 plus tables. The system was able to drop it down to 1,700 indexes while retaining the execution time or the elapsed time, right? So we were still able to get, this slightly better performance impact, right? So compared to 1172 seconds of elapsed time for the entire workload to 1155. So marginal improvement in performance. But the big saving here was not having to manage 4,600 indexes, right? And instead get that same performance or better performance with 1,700 indexes. So this is for a very practical, large workload, such as an ERP application. Okay, so that's auto indexing. Let's talk a little bit about the other features. High availability. All of the technology that you're aware about, RAC, Exadata, Active Data Guard, rolling updates, application continuity, which I demonstrated in the Swing Bench demo, online indexing. You take the combination of all these features, and you can tell that it kind of handles pretty much every failure scenario, right? Things like flashback are pre-configured, available in the database, right? So even if it's an accidental drop of table or having to roll back to a point in time, you can do all of that using flashback. So again, all the features of the database that you know of, add to that the automation and the tooling, it comes together to create a highly available service. In July, as I said, we are very close to releasing the Active Data Guard feature that allows you to replicate your database across regions. So you can, at a click of a button, choose a database deployment with 2 Exadatas across 2 different regions, 2 continents if desired, and automatically replicating without any setup, without any maintenance, all of that. And so there's a slew of features that come with it, which I'm sure once this comes out, we'll do other webinars, and I'll be happy to walk you through what they are. But this is just a high-level heads up that this is on its way. Backups are fully automated and are taken to the object store. Archives are backed up every 15 minutes. Retention time today is anywhere from 7 to 60 days, and custom retention times are going to be available as well. So you can take a custom backup and keep it for as long as you want. Restore is at the PDB level or the database level, as I showed you, can be done by your DB admin, does not require any sophisticated admin or fleet admin user to participate in a recovery activity. Every user of the database can back up and retain and recover the databases. Patching is an important thing. So patching is the responsibility of Oracle. As I said, patches get released on a quarterly basis. And so as I showed you, you schedule the time when it be applied, and the quarterly patch would get applied at that time. And as I said, if you configure the right set of drivers in your application, it should be transparent to how the patching operation occurs. And so Oracle has quarterly releases, right? So we call those, annual releases. So this year it's 19C. By the end of this year, we are going to come out with actually 21. We are skipping 20, but right now it's 19. And so there are annual releases followed by quarterly updates known as the release updates. So 19.2, for example, is a release update. So is 19.3. And as you can see, they release every quarter. And you pick the time that when that release update needs to get applied. You can also choose to apply the revision only so that you can stay on a particular release update for a period of time while you get a chance to test out, right, an upcoming release update, but only apply the security patches and the bug fixes. Those get applied in the form of a release update release or an RUR. And so you can stick to applying RURs to your container database for a period of time until you're ready to go to the next release update. So you have, as a fleet admin, you have that control. A little bit about the security. Again, there's a lot of things that you would not need to do. And so by making sure that you do not have access to the CDB root or to the operating system, we keep the number of people that access that part to a bare minimum or to 0, I'd say, right? So mostly it's the automation that goes in, does the job. No humans get to the OS, makes it definitely secure. It definitely reduces the surface area of attack. Besides, of course, a slew of features around encryption, the way we use database vault to make sure that even admins do not have access to customer data domains. Again, a key differentiator is compared to other cloud service providers. The way the auditing happens, auditing is automatically enabled inside the database. All connections from clients are encrypted using wallets. There's an event notification service that you can subscribe to so that key database events, service events, you get notified either over an email or through a Slack channel, or if you have PagerDuty, you can get paged. Many different ways of keeping notified on what's happening with your database. And of course, the service is undergoing compliance certification. By the end of this month, we expect SOC 1, 2 ISO certifications to arrive. Early next year, we plan to get even HIPAA by the end of this month, by the way. And then early next year, we plan to have PCI and FedRAMP achieved as well. Now, I've already talked about the separation of duty. I think we have very little time left. The separation of duty adds to the security aspect of the service, so that's why I want to highlight. I think it's important. Not to mention that, as I said, all connections are highly secure. You have the option of wallet-based or certificate-based access, but applications that do not have the capability of using a wallet can still connect to the database over regular SQLnet, over an encrypted SQLnet connection using the native network encryption. We also provide a separate service, a security service in the Oracle Cloud called Oracle Data Safe, which allows you to create security assessments, data masking, data discovery, a slew of features. And so it's a separate service of its own, and it's actually free or included with the Autonomous Database, right? So if you're using the Autonomous Database, you have free entitlement to using the Oracle Data Safe service, which gives you all these features. And then finally, a little bit on how it empowers developers. I will definitely hold a separate session at some point in time, because this is a topic that can, I can talk about for a while. In the interest of time, I'd say everything that the developer needs to be able to create databases quickly, make sure they're enterprise class, meet their enterprise standards in terms of security and availability, but do it with ease and without jumping through hoops. All the tools are available. SQL Developer Web allows them to monitor at a high level that the database is actually functioning as per the requirement. Tools such as Apex are built in. So for low-code developers, line of business developers who quickly want to put applications together, they can use Apex, comes out of the box. REST data services come pre-configured. So if you're building applications that want to talk to the database over REST rather than SQLnet and loosely coupled applications, you can do that out of the box. All of the typical orchestration interfaces, Terraform, SDKs, all of these are available. So these are very standard tools basically out there in the industry. And the service works, using whether you use REST APIs or whether you write your own automation using your favorite language. There are language drivers available to enable you to do that. Being able to use the database service with, for example, microservices architecture, a container-based service in the application tier. The database service, in a way, provides a comparative container service in the backend for the database. So I showed you that in one container, you have multiple pluggable databases, which gives the agility of cloning a pluggable database, moving it between one container to another. And so it's a very comparative architecture, and it becomes very suitable for container-based application development as well. We also provide an image, ready to develop image in the Oracle Cloud Marketplace, which has all the drivers and everything I mentioned preset for app development. So you basically go to the marketplace, drop this in about, I would say, a minute, and you are in there, and you can hook onto your database and start writing applications. Pricing model is subscription-based completely. You get a quarter rack or a half rack or a full rack for the hardware. There's a subscription cost. The minimum is actually 2 days, so you can even get it for 2 days. And then all of the databases you deploy and you pay as you go. So you drop a 1 OCPU database, you just pay for that at an hourly price. This month we are making it per second billing for the autonomous database as well. And so you really pay for what you use for. And all the scalability features is, as I explained earlier, come in to drastically reduce the amount of or the consumption, and make sure that you only pay for what you consume. So in summary, I'd say the key takeaways are that you would deploy the autonomous database dedicated infrastructure to reduce your ongoing maintenance costs, improve your uptime, as I showed you earlier, create secure configurations, provide the highest availability, and enable your developers to build applications faster. So with that, I come to the end of my presentation, and I turn it back to the moderator.
Hey, thanks, Chris. Chris, there are almost 11 questions. Why don't you pick some valid questions and answer in next 10 minutes?
Sure. Okay, I see the questions are in the chat. Okay.
Not in the chat. Why don't you pick from Q&A, because we asked to put it in Q&A panel.
Oh, so you want me to ask the questions as a quiz?
No. There are questions from participants. Please, you can see the Q&A panel, right?
Oh, I see. Okay, in the Q&A. Sorry, my bad.
Yeah.
So let me start
So
sharing
pick.
first.
Yeah.
Oh, okay, I can see them now. I'll go in the order. So first question is, active data guard needs to be set up by the customer, or is it automatically configured? The answer is active data guard, when it's available starting July, will be automatically set up. You will pick, when you create the container database, you would say, does it need to be in a single region, or does it need to be across 2 regions? And so when you do that, you say pick region A, region B, and you say create an active data guard configuration. It's going to go ahead and deploy the container database across both regions, right? So it's as simple as that. And the fleet admin decides which container databases get replicated across regions, which are single. And so when a database user comes in, they create a database and they deploy in that particular container. And accordingly, it'll either be replicated or in a single region, right? So I hope that answers your question. Okay, so more active data guard question. Okay, you have enabled auto scaling. When do I use auto scaling versus manual scaling? Auto scaling, I would say you would turn on for pretty much every OLTP application, because that way you can start with a low count, right? So let's say, you have peak periods where the database needs twice the number of OCPUs, but most of the times it needs a baseline. So you'll start with the baseline, and then it'll auto scale to whatever you need, which the max is 3x, of course, of the base. And so that can be leveraged for any app. But let's say something major is happening, and you decide, oh my God, even beyond auto scaling, it's shopping season, and so I need more OCPUs. Or take this situation, for example, the COVID situation. Certain businesses, you have more traffic coming in, more people shopping online, and you suddenly decide you need more hardware for your database. You can manually go in and do that, right? So both the options are available. Yeah. So if the CPU increases online, what about the dependent functionalities like the SGA, PGA, huge pages? Good question. All of these expand accordingly. The resources that the database gets, the concurrency that it gets, parallel threads that you get, the cache, the SGA, the PGA, all of that grows proportionate to the number of OCPUs assigned. So when you increase the number of OCPUs, all of these assign and grow accordingly. And the SGA target also changes accordingly, right? So it makes sure that all these aspects are covered. Can the auto index mode be changed from the OCI console? Not today. Today you have to go to Enterprise Manager or use basically SQL. But yes, very soon we are going to add the ability to do that and monitor that from the console. And then the question is, core that is provided, is that an actual core or a hyperthreading? We are very particular about that when we say one OCPU, that is equivalent to one physical core of the OCPU, and it gives you 2 threads, right, in the current model that we have. So it's not hyperthreaded, it's a full usage of a physical Intel core is what you get. So yeah, I hope, given the time, these are the questions we can handle.
Many thanks, Chris, for your continued support and time. We really enjoyed your presentation as always. Hopefully we'll get your time next presentation very soon. Let me share my screen now. Hope you can see my screen, right?
Yes, I can. Thank you. Thank you for hosting me. I look forward to coming back again and bringing the latest that's available in the Oracle Autonomous Database Service to all of you.
Yeah. So as suggested earlier by Arpit, please use hashtag of Chris. Twitter ID is K Bansali. And you can thank him by tweeting or posting in Facebook. We will send you a speaker survey today or tomorrow to all registered participants. Request you spend a few minutes of your time and complete the survey, and then you are able to access the presentation. We are also happy to provide a certification of participation if you attend all the webinars in this month. If you have any questions, please reach out to webinar@aiog.org. Now the exam time. Let us test your knowledge on this session, and we will run 5 questions for this. You need to use menti.com. Let me share. I think Chris is so generic, and he provided really simple questions. Let me share the screen.
Let me tell you that some of these questions have been borrowed from the Autonomous Database Certification. So for those who are intending to certify themselves, right, I hope you listened closely to the webinar, and these questions might help you a little bit there as well.
Yeah, thanks. That's really great help. So guys, your job is to go to menti.com, use the code 344008. So I'll wait for at least 2 minutes because there is a delay in YouTube. So go to menti.com, use code 344008. And since the questions are really easy, so your job is to press the button very quickly. Yeah. So whoever pressed the button means basically answer the right answer, they'll get into the top leaderboard. Yeah, we have 28 now. Even if it is not reached half of the participants, I'll wait for 1 more minute. And please provide if your full name, don't provide nicknames because otherwise we can't identify the name and you can't get a voucher. Okay, so I'll start now. So as I mentioned, answer first to get the highest marks. Okay, so we have 27 answered right questions. I need to check why it's not going to the next page. One second. Sorry for that. Okay, let's see the leaders board. So we have Harihar. He's the fastest in the leaderboard. Let's see the next question. Okay, that's excellent. Leaderboard. Still Hari is on the top. Tyagarajan is coming up. Let's go to the next question. Okay. Let's see the leaders board results. Okay, Tyagarajan is coming up now. This is the fourth question now. Superb. Let's see who's in the leaders board. Yeah, fastest is actually Pavan, but still, yeah, let's try one more try. This is the last question. Okay, here is the winner. Let's see. Wow. Congratulations, Tyagarajan. We will contact you offline for sending the gift voucher. And let's see who's coming next week. So we have next session coming from Lonika Dikmans. She's a global CTO at eProceed, and she's also a Groundbreaker ambassador and Oracle ACE director. She is going to present on building a microservices architecture, a case study. So this presentation is basically covers Oracle cloud infrastructure and microservices architecture, and this is a real-time, real case study. And she will actually walk through the Kubernetes cluster using Terraform, and also she will cover Node.js, MongoDB services, and leveraging Oracle Developer Cloud Services. So it's going to be an interesting session. So please join. It's on next week, 20th of May, 2 p.m. IST. Okay. And please check your mailboxes for a speaker survey so that you can access Chris Bernisoli's presentation. And with that, I'm closing the session. Thanks once again for Chris for your continuous support, and we'll see you soon. Thank you.
Thank you, everybody.